In this video, we are going to be using the spectrophotometer to measure the absorbance in our dilutions. In this clip, Chelsea is putting the stock solution into a cuvette. In this clip, Nun is putting our first dilution into a different cuvette. In this clip, Anna is putting our second dilution into another cuvette. In this clip, Jamie is putting our third dilution into another cuvette. And lastly, Jamie is putting our blank solution, which is water, into our last cuvette. In this, Jamie is cleaning our cuvette and putting our blank solution into the machine so that we can zero it out for our blank solution.
The Beer-Lambert law states that the relationship between concentration, molarity, and absorbance of the solution is linear. The variable A means absorbance, E means molar absorption coefficient, C is the molar concentration, L is the path length, and the blank being zeroed will cause any light being absorbed by the solvent to be neglected. In this case, the solvent is the NH3 molecules.
We clean both sides of the cuvette so that the spectrophotometer can read the absorbance of the solution. Place the cuvette in the machine with clean sides towards the beam. Close the door before scanning. Scan the absorbance and record the value in your notebook. Make sure to carefully remove the sample and shut the door when you're done. Make sure to clean up your station. This is our lab notebook with all of our data that we collected from the spectrophotometer. We used the C1V1 equals C2V2 equation to find the concentration of each solution. In this experiment, we scanned the wavelength at 560. The lambda max is the wavelength across the absorption spectrum where a substance has its strongest photon absorption. In order to find this wavelength, we must scan across all of them to find the right one. We also scan across all wavelengths to make sure that we do find the strongest one, because we could find one, but it may not be the best to collect data from.